All right, please give it up for our game master, Vamsi. Joke's on all of you. You can all get free t-shirts at the front. So everyone's a winner here. Are we live streaming yet? IT? We are? We are live streaming. Okay, cool. Tweets. First, my name is Jonas, founder and CEO of StackShare. Real quick thank yous to Sharon, aka Stack Sharon. Please give her a round of applause for helping to organize this. And Haley, where is Haley? She also helped in a major way coordinating all of this. Thank you, Haley from Flexport. And last but not least, Desmond and Cody for having the vision. Thank you. All right, so for those of you who don't know, StackShare is the best place for you to find out what a tool does and who uses it. Our mission is to help make developers more productive by helping you learn about these technologies through the people and companies you trust. So, current state of affairs right now, as you all know in this room, tools are really confusing. There's a lot of them. Some of these have actually been shut down, so this is old. But it's pretty confusing. And what we do is clean it up and help you understand how the different tools fit into your tech stack. And we're calling this the technology graph. And so to date, we have over 200,000 developers that use StackShare every month to help them make technology decisions. Well over 10,000 companies like Flexport that are sharing their tech stacks, and well over 1,000 software vendors like Heroku, GitHub, SendGrid, all the big players. So we bring them all into one place and help you understand the tools so that you can make better decisions. Our stack, as you could have guessed, is Rails and React, Ruby, and a new addition is GraphQL. So we have started to adopt it for a new product that we're building that we can't tell you about just yet, but we are a Rails and React shop, and we are, of course, hiring. This is the current team. We're small but growing. We're 10 people right now, spread out. We just got our first office here in San Francisco, so if you're by South Park, tweet us, hit us up, stop by. And we are looking for React engineers. So if you are an engineer and use React and you're excited about the idea of connecting developers with tools and the awesome companies that use them, visit stackshare.io/careers and you can learn more about our mission, vision, and values. And now I will give you a very quick story of how this meetup came about. So back in 2016, we actually sat down with Evelyn. Are you here? Vacation. Damn it. All right. Evelyn and Desmond is here. OG. All right. So actually, I just remembered this because he reminded me. We met at a conference, and he was introduced as the React expert. And I actually thought he was on the core React team, but he is not. He's at Flexport. So we did a podcast, and I'll play a short clip from it, but we stayed in touch, and we started thinking about, can we do some sort of event in San Francisco? Everyone's been to a Rails meetup, right? Everyone's been to a React meetup, but you have never been to a Rails and React meetup. So this is the first one that we're aware of. Clap it up. First ever in the world that we are aware of. So this was just like a genius idea that we thought of, and coincidence, we both use Rails and React. Flexport is built on Rails and React, and so are we. So this is what we came up with, first of many. And as we started to think through who should we invite, we thought about this clip.
That blog post,
Yeah.
which is really good. So, I mean, when someone has a request, it gets approved, and then as soon as it's mentioned monster, it's immediately deployed. It's a manual step to deploy it. It's a bunch of capture Rhino scripts.
Playing it to EC2.
Yeah, exactly.
So with the tests, Well, the tests are running on Travis, you said?
No, well, we wait till the test pass before
Hold on
we
a second,
before
guys.
Ours is nowhere near as fancy as that. Actually, ours is inspired a lot. Well, at least in my opinion, it's inspired by Zach Holman's deploying software blog post.
Yeah.
Which is really good.
remember that, yeah.
So, I mean, when someone has a pull request, it gets approved, and then as soon as it's merged to master, it's immediately deployed. It's a manual step to deploy it. It's a bunch of Capistrano scripts.
All right. We don't need to go into the details there. But the point is, back in 2016, their entire deploy process was built indirectly by Zach Holman. And he is here as our first guest for the Rails and React meetup. So we're really excited to have you, Zach. And that's how Zach fits into the whole equation. And he's, of course, a good friend of StackShare. So I'm going to actually let Flexport kick it off here. I think first up, Matthew, are you here? All right. Thank you, everybody.
Just let me 30 second. I'm going to try and make sure I can see some notes and hopefully I get them in the right place. That's not right, is it? Hang on. Uh oh. You know what? Let's wing it. I've got some notes written down over here. All right, so let me get going. No, it's okay. Don't worry about it. So I want to start with a confession, and this confession is kind of a dangerous confession, I think, to make in the Rails world. I actually have mixed feelings about RESTful JSON APIs. Like, don't throw any rotten fruit or anything. There are really good things about JSON. It's human readable. It's unfussy. It can be really great for the API layer that powers your front end because it works well with JavaScript. You get these nice JavaScript objects out of it. But I also think there's some pretty unpleasant ergonomics often with JSON APIs. And we've run into some issues. I want to talk about some of the issues that we've run into using JSON APIs and why we ultimately ended up using GraphQL in some parts of our application. So we first ran into this pain when I was working on our network team. So network is kind of a fancy term for the part of our application that lets customers manage data about the companies they work with, the locations that those companies have, and the people who work at those different locations. So we can think of the data model as being there are companies and there are locations associated with those companies. So you can imagine maybe we're a freight forwarder. So maybe a manufacturer, it has many factories. And there are many people who work at those factories who you might need to contact if you want to pick up goods from the factories. So these are all kind of many-to-many relationships. So this is, we have like a UI that you can manage this through. We have a whole bunch of companies, the locations that this company has access to, the contacts they have access to, and then you can drill down in detail. You can see a company has a bunch of locations and contacts. You can see that there is a location that has a company and contacts. And you can see that there's a contact and it has a company and a bunch of locations that it's associated with. So what you find is that this data is associated in many directions. You want to show information about companies on locations, information about contacts on locations, vice versa. So the way this works, right, is it's a pretty traditional kind of Flux, React, REST-ish API kind of thing. So we have these stores, we have this kind of broad component wrapping this part of the application. And when that component is mounted, we fetch a bunch of data from these stores, and then whilst it's loading, we show a loading spinner. Once it's loading, we're going to show some interface that passes that data down. It's probably a pretty standard thing that everyone's familiar with. But as we mentioned, we want to show data kind of across sections of the application. We want to show we want to show information about contacts on locations, information about locations on contacts. And the way we do that is, like a lot of people do, we had some kind of cross-store dependencies. So if I want to show all the locations that a person is a contact at, I'm going to go through and get all that data out of the location store. I'm going to filter it to the relevant locations, and that's the locations I'm going to be using. Now, this is okay, but I don't think anyone really likes doing this sort of stuff. It's kind of brittle. It's easy to make kind of mistakes, to have data that's out of sync. And it really doesn't work when you paginate. These dependencies across resources are really unpleasant because I've loaded into a third page of locations. but I haven't loaded the kind of corresponding contacts that my IDs are referencing. So it doesn't really work well. And like I think what often happens in applications to solve this problem, and generally to solve this problem that there is lots of data getting shown in lots of different contexts, is that people start to have lots of different JSON variations. Um, so you obviously can't do this. Uh, you can't make the kind of nesting of data work, which is what you want to do to avoid this dependency work, unless you have JSON variations. Otherwise, you're going to obviously nest independently. So what happens is you introduce these JSON variations. You're going to have JSON, the kind of the standard JSON that you've written for like, here is how I'm going to represent my object in JSON. And then I'm going to say, well, but sometimes, I need to have information about a contact for a location nested inside that location. So I'm going to have JSON summary. And then you say, oh boy, this is too much information to return about my locations when I'm just showing them in a list. I don't want to show all that detail, so I have JSON list summary. And then what I find is, oh boy, okay, well, I actually have this UI that wants even more information. Some of it is more expensive, so I have JSON expanded, and it carries on. You get more and more, and it ends as naming schemes always do, which is JSON latest final use this version. So we were sort of finding ourselves in this kind of situation, and it's not really. No one really likes being in this situation. I really wanted to avoid this. And so, looks like kind of for us, the straw that really broke the camel's back on this madness was pagination. We really wanted to find a way to introduce pagination to this UI because you can't load all the information about all the companies a company works with the second that you come to your interface. It's too slow, it's too non-performant. So yeah, so we really wanted to find a way out of this problem, and thankfully there is kind of a way out of the problem, which is GraphQL. So GraphQL is technology. It's out of Facebook. I think the protocol was released in 2015. And at Flexport at the time we were running into these problems, we'd played around with using GraphQL a little bit. We'd used it once or twice on a few small features, but we hadn't really committed to using it. I think there was some uncertainty about whether we really could use it. We'd had a few projects where we tried using it that hadn't really gone very well, and trying to move things over to it was kind of scary. But in the end, I think we actually had a pretty satisfying experience using it. So I want to explain a little bit about why it was appealing, what we found useful about it, and also what some of the strategies that we took that made it a little bit easier to adopt it in existing areas of application were. So, going back to this example of a location and its JSON, right? You can imagine having this JSON format. It's got the name of the location, the address, and then information about the company and the contacts. And you can imagine having a summary variation as well that maybe doesn't have that embedded, nested information. This probably seems familiar, and like I think you probably have something like this in your code base. So what we do in GraphQL instead is we think of having object types. And object types, I think you can think of this as being kind of like the superset of all of the JSON structure that you have in all of your JSON formats. So we say, a location can have a name and an address. These are kind of primitive values. And it can also point to other types of objects. It can point to people and companies. So this hopefully makes some sort of sense. You're really, like I said, you're really creating kind of a menu of all of the information that's available in JSON. And then instead of having a whole bunch of kind of these REST-style endpoints, where you're going to make a request to them and get, generally speaking, a fairly fixed set of information back. Generally you hit the people endpoint, you're going to get back some pretty fixed JSON. Maybe there's like one or two variants that you can choose between with some query string, but usually you get back what you get. Well, instead, what we're going to say is we have this top-level entry point to our application. We're going to call it query type, and it has fields. And these fields are going to return things of a certain type. So locations is going to return an array of things conforming to this location type structure. And we're going to resolve it by giving you all the locations visible to this company. And so what this means is that when I want to get data out, I'm not just going to this kind of endpoint that's been preset up and it gives me back some preset set of information. I'm using these entry points into my application as a starting point from which I can basically explore all of the relationships. And then I'm just going to get the data back that's exactly what I requested. So if I wanted the name and the address, I get them and I get the name from the company and all of my contacts with their name. So the other nice thing about this though is that if we want to get more information, that's totally fine. Because in our structure, in our schema that we defined, we've defined these relationships, we've defined everything that's available. So if I then say, hey, actually I want to get the phone number as well for my contacts because I want to put it in my UI, and maybe I want to get all of the contacts that belong to the company for this location, then that's fine too. Maybe I want to build a UI that has something where I can select which contacts should be associated with it, and I need to have all the other people available to me. That absolutely works. And it's not like when you come across this problem and you're using a traditional JSON API, where you now have this problem of like, well, is this like a new JSON format? Am I modifying an existing JSON format? Which obviously might have some costs for areas of the application that don't need that data. It's just, say what you want and you get what you want. And anyone who doesn't want it hasn't requested it, so they don't get it. And so the nice thing about this is that it also plays really nicely with other aspects of the front end in your application. So we use flow typing to give static types for JavaScript. It's fantastic. It's really improved the quality of our code. And you can generate those flow types from GraphQL queries. Given that as we talked about, right, we know what the type is of those objects and fields in our schema. So when we have a particular query, we can say, hey, the JSON object we're going to get back to is going to conform to this very specific format, and it's going to have these very specific types, which is, kind of a useful feature. And the front-end library support is really great. So this is an example using Apollo. There are two kind of compelling options for front-end libraries to talk to GraphQL APIs, Relay and Apollo. And you can see we're just going to define a query. We're going to get back the name and the address for every location. And then we're going to have a component. It's going to use this query component provided by the React Apollo library. It's going to fetch the query. And then, we're going to get an inner component that it provides these props to. If we're loading, we can show a loading state. If we have an error, we can show an error state. And otherwise, we can show like our actual inner interface with all of the data that we fetched. So that's, pretty cool. But I want to actually talk about like what it's like to use this and some of the problems that you're going to come across and how you can perhaps make it more tractable. And in particular, as I mentioned, I want to focus on how do you move over existing code to using GraphQL. It's really easy, I think. Well, I don't want to say easy, but moving greenfield areas of your application over is a little bit easier. You don't have this conflict of approaches. You probably built your software under a whole bunch of assumptions. In our case, we assume that we're working in a Flux world. And now we have to work in this world where we're not using Flux stores, we're using GraphQL, and it requires a different way of thinking. And that's just kind of tricky, Some of the things you would like to do don't make so much sense. And the second reason why I think it's really interesting to talk about moving existing areas of your application over is that when you do that, it proves that you can, and it often proves that, hey, this might actually be a better fit for the problems that we face. So if you have a part of your application, and it kind of works with Flux and REST-ish endpoints or Redux, but there's some ergonomic issues. If you can move that over to using GraphQL and it works really well, I think that's a good sort of proof for you that, yeah, maybe this is worth doing. So what do I want to talk about on this? I think that a good place to start is what does kind of the back end look like? What changes do we have to make in our Rails application, for example? So I think the first thing that you want to do if you decide to adopt GraphQL, and hopefully this will go down since this is a Rails plus React meetup, is don't change your API technology. Whatever your API is currently written in, use the same thing. I mean, the reference implementation, I think, for GraphQL is in JavaScript. It's a Node.js approach. And, yeah, you could use that. I'm sure it's fine. But the Ruby gems around this are pretty decent. They're certainly good enough. And you don't need to change this. It's really going to make your life simpler. And I think the other big thing about this is don't change your object model. However you structure your JSON object is the same way that you should really end up structuring your GraphQL objects in the near term. So if something is an object in your current JSON formats, keep it as an object. If it's a field, keep it as a field. And actually, sometimes you might find that In practice, some things end up being both in your current JSON formats because often we get sloppy. Let me give you an example of this. At Flexport, we had JSON structure for locations, and I think at some point we had like a company name field, which is sort of reasonable. It kind of is useful. I want to be able to show the name of the company this location belongs to. If we're being kind of purists in the GraphQL world, and generally purists full stop, we don't really want to do that. We probably want to have a nested company object that has a name. Except it's kind of painful to make this change sometimes. I know this might sound silly, but like there's a good chance that you have a whole bunch of components throughout your application that expect to get an object that has company name. And if you say, hey, no, all that code, I need to rewrite it to be company.name, I mean, is that the end of the world? No. But it's a whole bunch of risk that you're taking by changing even more areas of the application. So I'd actually suggest that what you do is you just make both things available. And this is like not really the right thing to do in GraphQL. But I think if you take these sorts of shortcuts, if you maybe make the same information available in your schema in two places, you're going to find it a little bit easier just if you keep that compatibility with what you had before. And actually, that brings me to the other big thing here, which is please, please, please don't start by making a public API in GraphQL. Now, some people have used GraphQL for public APIs. I'm not saying it's bad for that necessarily. I think it's a better fit for building APIs that power front ends than it is for like a general purpose API that you might, for example, integrate with your from your backend. But the biggest reason why I wouldn't recommend starting with a public API is that you're probably going to make some mistakes designing your schema. I know we did this. There are lots of things in our schema that just aren't quite right because we didn't really know what we were doing. Which is, I don't know. I think that's okay to admit sometimes. The only best way you learn things is by doing them. But those mistakes are much easier to correct if you own the code that consumes the API. You know, if you own the front end code that talks to this API, you can change it. If you can deprecate something, and then you can get rid of it. Generally, GraphQL has this culture around not deprecating things, not getting rid of fields. And I think that's great in the abstract. In practice, as someone who's new to using technology, you're going to make mistakes. And I think the best thing you can do is make sure that you have the ability to correct those mistakes and not live with them forever. So by extension, you should also probably consider using this to power maybe a web app rather than a mobile app. In general, native apps are going to have, longer release cadences. It's much harder to roll out a change and then be confident that no one is on the old version of your client. So I think that was probably something that would help. I think the other thing I'd say is really aggressively limit the scope of what you do. So just move a single interface area of your application over to using GraphQL. Don't feel like you have to move everything over. But by extension to that, I would think about it in terms of moving interface areas from using, say, Redux or Flux to using Relay or Apollo backed by GraphQL. And when you do that, what you're probably going to find is that there are areas of your application that still rely on those old endpoints and those old stores, right? You know, if you've, let's like for example, we moved over all this network UI to using Relay, but there are still parts of our application that use locations and companies and contacts. And if we'd have tried to move them away from using those REST-style endpoints, we'd have actually had quite a lot of work to do, and it's hard to know where to stop, because then you need to move their components over to using Relay. Once you move their components over to using Relay, it turns out that, okay, well, that has a knock-on effect, because now we're getting this other bit of data through GraphQL. So now this other bit of the UI has to also get moved over to using Relay. And it never ends. You have to kind of just draw a line somewhere. And I think having two ways to get data is okay in the short term if it lets you draw a line and scope your project reasonably narrowly. The other thing is, please, maybe don't do mutations. So again, this is an experience that I had with this is GraphQL has a pretty good model around modifying data, around editing, deleting, creating information. And it follows a lot of the same principles as the query system. And it's really great, and I think you absolutely should use it in the long term. But something that we found pretty effective was we kept getting this information through our existing, writing this information through our existing JSON API. And all we would do is, fetch the data that we needed via GraphQL queries to power our form UIs, talk to those endpoints, When they return successfully, we just imperatively refetch the data from GraphQL. This is kind of hacky. It's not really something I'm hugely proud of, but it actually meant that we could really change over pretty quickly and effectively. And the other thing I'd say on that note is like, don't use every smart feature that exists. And this is especially true in the front end of your application. So Relay and Apollo, as an example, both have a concept of fragments. So I can co-locate the data that my React component needs in the kind of GraphQL format with that component, but then I will actually stitch those fragments up to get up and join them together into a single query in some kind of higher level component. Now that may or may not have made any sense, and that's almost kind of the point of it, is that it's another kind of bit of mental space that you have to occupy. It's another kind of thing that you have to think about. And you might find your life a little bit easier if you just don't use this feature. It's not that it's not a great feature, but it's not something that's essential, and you might have more mileage if you just kind of skip these features. If they don't seem that useful to you, don't do them. Some specific advice is, I would say use Apollo. We use Relay. It, it's fine. This is actually, like I said, there's a reason I'm hedging this so much. It's a pretty marginal decision. Like, I think the big difference, Apollo is a little bit less opinionated than Relay is, and it's also got a better community. And I think those two things make it worth using. But at the same time, it's so marginal that if you have a compelling reason to use Relay instead, and a good example of that might even just be that I think Relay support for Flow is a little bit better. Um, Apollo support for TypeScript is a little bit better. So if you're using Flow, maybe Relay just about is worth doing. But I'd bias towards Apollo. And the other thing is just ignore me. Um, these are kind of things that I sort of found as I worked on this. These are some of the corners that I kind of cut and that I found made the whole project a little bit more tractable. But your use is going to be different. So maybe the way that you interact with a Redux store means that using fragments actually makes a lot of sense. You have all these Redux-aware components, and you can instead make them GraphQL-aware. Yeah, if that works for you, you should do it. But the central thing I really want to say is that there are some things that you might be able to skip, and it might make your life easier, and you probably won't regret it that much. So I want to leave with some final thoughts. I have three of them. First one is just think about using GraphQL. I think it's a really good alternative to kind of REST-style APIs. It might not be a good option for you, and you may have heard me talk about this and think, "Oh, that sounds crap. I don't want to use that." That's fine, but I would recommend thinking about it. It's pretty useful, and I'd especially say so if you have a very interdependent, very complex data model. This is one of the big problems we have at Flexport is our data model is very complex. It's a very complex domain, and our data model is very interdependent. So we do have these use cases where I want to display information following through like 3 or 4 associations in some context. In other contexts, I don't. So it works really well for us. It's very good for exploring those kinds of things and giving you options for what you show without necessarily forcing you to have a billion JSON structures. And the final thing is just reject these feelings. Don't feel guilty or anxious or like you're missing out on purity if you skip things. I think I actually think it's really hard to adopt new technology and new paradigms because they just do have this mismatch with the paradigm that we were following before. And it's tricky because like the whole reason why we want to adopt a new technology is not so that we can just write code the same way we always did. It's so that we think we can unlock better code, we can be better developers, we can be more productive and write more reliable and resilient code. So yeah, we want to do these things, but sometimes it's really, really hard. And the value of doing it in the short term isn't always there. So, it doesn't make you bad or lazy or sloppy. I think it's just sometimes a conscious decision that you make is, I'm not going to do this the perfect way, but I'm going to do it the good way. And I think for us, I think this was the biggest lesson that I had was that I'd say the work that I did on using GraphQL was okay. But by doing it, we now had this part of our application that we'd moved over, And moving over to using GraphQL wasn't this like spiral of chaos. We didn't get stuck in bike shedding. It didn't take forever and ever, and we didn't have to like rethink everything we were doing. We just spent a few weeks on it, and then it mostly kind of just worked. And I think that proved to the teams, hey, you can adopt this too. You can move your code over to using it. Your new project, yeah, if you work on it using GraphQL, it will probably be really productive, really effective. And I think now we have a lot of teams that are using GraphQL. They're all doing it so much better than I was doing with GraphQL. They're using many of these features. They're doing things the right way. But I think it really helped that we'd proven, yeah, GraphQL can work for us. So I think that's the big benefit that you get. So thanks for listening to me. I didn't have any speaker notes in the end, so hopefully that wasn't excessively rambling. Um, yeah, Flexport is hiring. We're solving lots of interesting and hard problems in how to automate global trade. We use React and Rails and GraphQL. Yeah, and if you want to talk to me about GraphQL, that sounds great. Please do. You can email me. You can talk to me afterwards. Don't tweet at me because Twitter is the worst thing in the world. Um, it's too dangerous. Too dangerous. Yeah, thanks a lot. Oh, we have a question. Mhm. We don't. We have a big old monolith. Cool. All right. That sounds awesome. If anyone didn't hear that, gRPCs in Rails. It's great. Cool. I'm not going to take generally questions because we need to keep it moving. Cool.
All right, hello. My name is Stefan. I'm an engineer here at Flexport, and I'm going to be talking to you guys today about scaling a web app with code splitting. So code splitting is a technique we can use to reduce the amount of code we serve to the client to render an initial page. And Flexport had some feature explosion, and our app got embarrassingly large, so we had to do something about it so that we weren't laughed out of every tech conference. Great. So I'm going to be talking about first a typical web app and how we normally serve JavaScript and how most apps serve a JavaScript. And I'm going to talk about some of the challenges associated with that, especially from the performance side and how it can impact your initial page load speeds. I'm going to talk about two solutions we use to address this problem. The first is route-based code splitting, and the second one is asynchronously loading your components. And then lastly, I'll cover some of the improvements we saw in performance after we implemented code splitting. So this is the shipment list page on our internal app. It's just a list of shipments. It's what our ops use to kind of triage what shipments they need to look at. You can see there's different statuses for each shipment. There's some due dates. There's some actions that need to be taken. But really, there's not a lot of logic that goes in here. The amount of code you need to render this page is fairly small. And yeah, so this is a shipment list page. So when you first make a request to core.flexport.com, you get served back a bunch of HTML, CSS, and JavaScript. That's nothing new. Your browser uses that and renders the page. You get a shipment list page, and on you go with your day. So typically, in order to get these JavaScript files, you have to compile it. So we have our source files at the top. We send that into Webpack, and then Webpack spits out a concatenated version of those files that's minified and production ready. And this app.min.js file is what you're going to serve to your client. And it holds all of the code for your entire app. It's just one big bundle of code. Now let's say I'm an ops user and I want to get some more information about a shipment. So I'm going to click on one of these rows and go into the shipment details page. Now this page is way more complicated. There's a route editor, there's action items, there's a ton of forms. And this is like the golden case of feature explosion at our company. This uses way more code than it probably should. So this is kind of the problem we were tackling. So in our world, we made our initial request to core.flexport.com. We got all our assets. Now we click on the link, and we're going to go and contact the server again. This time, we don't need to load any JavaScript or anything because we already got everything for our app on an initial load. So we're just going to load some JSON data back to render the page. So all of the cost is front loaded onto the initial page load, and every subsequent navigation to different pages is fairly fast since all you're doing is just loading a bit of data. So that works excellent for very small apps, and that's not complicated at all. But like I said, you run into some problems once you start scaling as an organization and your app starts getting bigger. You start really having poignant uh, some poignant challenges related to initial page load speeds. So this is a graph of the number of engineers over time at Flexport. As you see, it's going up and to the right. We want to keep going up and to the right. We're hiring lots of engineers, and that's great to increase velocity. And yeah, it's helping that a lot of people are pushing code to our base, but that also means that our code is growing like crazy. In 1 year, our app grew from 1 megabyte to 2.5 megabytes. So these are compressed numbers. So this is what you're downloading from the server every time. And 2.5 megabytes is pretty crazy. So this shipment list page that doesn't require a lot of code, even though no features were added, there's no new value added in that 1 year span. But now we're adding an extra 1.5 megabytes to download this page every time. Other people were pushing features to the other parts of the app, which was then slowing down the time it took to render this page. And that's not something that we want. Now, we could be using the browser cache to save off some of those requests and avoid an extra network request. However, we weren't doing that at all. With every new change to the code base, we were invalidating the browser cache. And let me just quickly explain how browser caching works so you can understand why this is such a big problem. So when we compile our files with Webpack, we shove them into a hash function, and it spits out a 20-character hash, which we append to the file name. Now, this hash is dependent on the source code, so the input to this hash function is the source code. When you make a request to the browser will first look into its cache to see if you've already made a request to that URL. If you haven't, it's going to go talk to the server, and then download the file and cache it locally. And all subsequent requests to that same URL is just going to pick it from the cache, and it'll be much faster. Now, you need to make sure that when you create new versions or push new changes to your app, you need to download that code, and you don't want to be using what's in your cache and what's old. You need to always have an up-to-date version. So Webpack handles this all automatically for you. Since your inputs are the input to your source code is the input to your hash function, if any of your source code change, that means the output to your hash function will also change. The signature of your JavaScript will be different. Now, when you make a request to the browser, you have a different URL. It's not going to look into the browser cache because it doesn't find a match. So it's going to go get something from the server and download the new file. So that works great in principle. You can push new changes to your users, and they'll download new files. And then when you're not pushing any new changes, the clients are just using what's in their cache, and presumably it loads very quickly. So that's great in principle. In practice, that doesn't happen at all when you're only serving one bundle of code and have tons of engineers pushing features all the time. Your source code's always changing, which means your output file from Webpack is also always changing, which means you're essentially never reading from your cache. You're always going to the server to ask new files every time you deploy. And that was a good talk by Desmond about deploying, but yeah, anyways. So to recap, the two big problems we were trying to solve is our app growing out of control and the fact that we couldn't use our browser cache to mitigate some of these problems. So we needed to find some kind of solution, and the first proposed solution was route-based code splitting. Route-based code splitting is the idea that we should only serve the minimal amount of JavaScript required to render a page. So for my shipment list page, I should only be downloading code to render that shipment list page. I shouldn't be concerned with code that's not relevant to that page or not on the critical path to render that JavaScript component. So if we look back at our old world before code splitting, we make the request, we get back one single file, and it holds all of our code. In the code splitting world, we're going to get back two files. So when we make a request to the server, we'll get back an app.js file and an app shipment list file. So let me explain what's in both of those. So in my app file, this will be code that's shared by all pages and is required by every page. Things like your API, your router implementation, any logging, things that are absolutely required that every page has it at all times, since you're going to be downloading it on every request. The second bundle is the app shipment list bundle. So this is only the code required to render the shipment list page. The Webpack does something smart and can figure out how to create this bundle, and I'll just talk about that briefly in a second. So again, in my example, we're on the shipment list page and we want to get more information about it. So we're going to click on one of the rows and go to the shipment details page. But this time, the world is a bit different. Since on my initial page load, I didn't get all the JavaScript I need to render this page. I only got the JavaScript to render the shipment list page. So when I make my request and I navigate to my shipment details page, I need to first request from the server another bundle of code in order to render that page. So there's an extra step involved and an extra network request. So this is the one compromise that we make with code splitting, is that rather than front loading the initial page load with all the cost, we distribute it across the user session. As they navigate between links, they're downloading more and more of your code. So I was talking about Webpack can do this all automatically for you. Webpack can look at the dependency tree. So given an input component, so this case, the shipment list component, it follows all your import statements down and creates a tree. And then for all the files that it's touched and all the files that it sees, it bundles them up into a single concatenated file, in this case, our shipment list bundle. And this is done really simply with a single dynamic import call. This is the ES6 version. There's a ES5 version for compatibility. But it takes a single argument, in this case, the path of the component you're trying to load. You can give it a name using some comment syntax. It's asynchronous, so it returns a promise. And once that promise evaluates, you can just use the module as if you imported it in any generic way. Yeah, that's very straightforward to get all that power of being able to trace through the dependency tree. Now, for route-based code splitting, all you need to do is, for each route, you'll have a dynamic import. So for my core.flexport.com route, I just need to map it to a function which calls dynamically loads a shipment list component. And same for my shipment details route, I just need to map it to the shipment details asynchronous call. The end result is when you compile all your code, your source files are at the top, you compile it through Webpack, and rather than just having one single file at the end, you have multiple files for each page. You'll have one app file which is shared across all your pages, and for each route, you'll have a bundle of code, which you load only for that page. The one other caveat with Webpack is that you'll end up downloading duplicates of your code. So let's say, for example, my shipment list and my shipment details, they share a button or something like that. This isn't code that's necessarily shared across all files, but it's shared between these two components. Webpack isn't smart enough to know that I've already downloaded the button code. So when you make the request for the shipment details page, you're going to download it button code again. So this is something we should take into account to make sure that we're not overly downloading too much code. You don't want to be asking users to download more code than they were before, because obviously that would be no better than we started. So now we have this world where we are only loading the required JavaScript for each page, and we've done it just based on the top level components for each page. But when we look at closely at the dependency tree, we notice that we're not quite there yet, and some of our bundles are still really big in size. And especially with the shipment details page, for the bundle required to load the shipment details page was 1 megabyte large, which is still huge for just rendering a table with some basic UI. So something was really fishy, and we had to do a little splunking to figure it out. And our intuition pointed out to a single button right here, which is what we call the shipment quick view. And when you click on this, it renders the shipment details page. So now we're no better than where off we started. When we load the shipment list page, we're also loading the shipment details page. The dependency tree looks like something like that. This massive blob of shipment details there at the bottom, and that's not helping anybody. So ideally what we want to do is, since we're only loading this when we click on this button, we don't need to load all the code for the shipment details right away. We can defer it to when the user actually clicks on that button. So ideally we have something closer like this. When we load the initial page, we load the shipment list dependency tree, and then on click, we can asynchronously load the code required for that shipment quick view component. All you need to do is, again, use a very simple dynamic import statement. This time our shipment quick view is the argument, and maybe when it resolves, we can add the component to the state, cancel our loading, and then display the component once it renders. So in practice, when you click on that component, rather than immediately seeing that component loaded, you have to wait for the JavaScript to be loaded, show a spinner while you wait, and then once it's ready, we get our nicely viewed component. Great, so we use two different types of solutions to address our problem of having a really big file size and cache invalidation. So that was route-based code splitting and asynchronously loading our components. So after we did all that, it's time to look back at the numbers and see how we did. So we saw huge improvements on this page. After chopping off that big dependency, we managed to reduce the amount of code to render this page from 2.5 megabytes to 568 kilobytes. Woo! So that's, we were very happy about that. So that greatly reduced the amount of code you need to download. If people are on slow connections, they're not going to get slowed down. The work won't get interrupted. Very happy about that. Now, I mentioned earlier about the code overlap and how that might be a problem. So I did a little spelunking to make sure that we weren't stepping on any toes. So I realized that 4 pages were our main contributors to our traffic, and these are our 4 worst pages in terms of size. Those feature explosion problems are definitely pointing, this is part of the problem that all our entire app is on just 4 pages. But even when you have code overlap and you download the bundles for those 4 pages, it's only 2 megabytes, which is still smaller than downloading the entire source code. So even in an unoptimized state where we haven't really done all the work of asynchronously loading all our components, we're still saving on the amount of JavaScript you need to load. Another often overlooked part of downloading a lot of JavaScript code is the time it takes to actually parse that code. When you download JavaScript from the server, you originally have to parse the code before you execute it. So with the 2.5 megabyte file, we were taking 400 milliseconds to download the code, which is insane, and that's a constant time that you have after downloading your code. With code splitting, parsing the 2 files, we got it down to 130 milliseconds. So going from 400 to 130, that's a big improvement in my book. The other part we were talking about was cache invalidation. So we wanted to try and make use of the browser cache more often. Since now we're creating a bundle for each page, it's not necessarily the case that you'll always invalidate the cache of your entire app. In this case, file 2 is the only thing that's changed, and maybe page 2 is the only page that depends on that file. So in that case, only this page's cache will be invalidated. All the other pages remain in the cache, and if you're not using that feature, you won't have any impact on your code. We built a cool tool to monitor all these changes. This is Flexport, who posts on your PR every time you make a change. And we can monitor how much we've increased or decreased all of our bundles. So this also tells us that 4 of our bundles caches were invalidated, and those will be required to be re-downloaded. Someone increased this one by 30 kilobytes, and they've been reprimanded accordingly. But this has been very useful, and we've been tracking this over time. So we were able to come up with this really cool graph of the bundle sizes over time here at Flexport. So you can see this blue line just growing out of control. And that was our mono bundle when we were grouping all of our app all at once. And you can see a sharp drop and lots of lines. And that's when we implemented code splitting. So each one of those lines is a different page on our app. And you can see most of them are sitting below 200 kilobytes, which is great for doing a naive implementation just based on pages. We still have those 4 problem routes that we need to deal with, which are floating way up above there. But some more work with asynchronous component loading, we can really reduce the size of those bundles. Yeah, that's the end of my talk. I hope you learned a little bit about how to load JavaScript on big applications. I'm sure at Flexport, everyone will be a little bit more aware of some of the impact they're having. But yeah, I enjoyed speaking to you guys. I'll be hanging around if you have any questions. Feel free to contact me if you have any questions. I'm happy to help. Thank you.
Last but not least, Zach Holman.
I do have a different thing.
Interesting.
Can you load it up?
Oh, is that you?
Okay, here's like the number one problem that we all face right now, specifically me. You got your mic in one hand, you got a beer in the other hand. Like, how do I look at my slide notes for all this sort of stuff? This is really difficult, and there's got to be some npm module I can install to fix this problem, or I don't know. Anyway, I'm gonna talk about best is the worst. This is very cryptic, like all good talk titles are. So we're gonna get into this a little bit. Today was really interesting because talking to a little bit people ahead of time. Some people kind of first day using Ruby, or very new to Ruby. That's really awesome. Still exciting to see people adopting Ruby and stuff like that. Talked to a couple people here who's this is probably their last day using Ruby, so that's cool too. We have a really big tent. We welcome all of you, even if you're leaving us, sort of. Um, so what I want to talk about today a little bit is obviously we heard a little bit about Flexport. Flexport has about 600,000 employees, I think, a large development team of a million or something like that. And I wanted to see kind of I think it's worthwhile to talk about a little different perspective. So I started a company called During. If I run the math, like, and figure out our head count right now, we're pretty much at about 2 people. Uh, so there's just me and my co-founder, a lot smaller. This is also very important to start talking about how does React and Rails play in this type of angle as well, because not everybody has like, money. Um, and it's cool because it's San Francisco, damn it. Like, we're gonna be stupid and build a startup and stuff like that. Obviously, this is like important for startups and stuff like that. But obviously, this is also just as relevant if you have a greenfield project at your big company. You're trying to figure out, oh, we have a new product. We can do new things. We can use new languages. We can do everything. It's amazing, and that has its own real problems associated with it as well. So yeah, startups are terrible, but they're really interesting and obviously fun and cool to learn more about. So that's what we're going to talk about just now. I'm Holman. Zach Holman is my first name. Actually, just Zach is my first name. Um, I worked at Guild. I worked at GitHub for 5 years. And now I'm building a company called During. It's a calendar that doesn't suck. Luckily, I don't have to sell it too much yet because it's not launched. The best time to have software is when you don't have any users. So I can literally just like ship stuff and it doesn't matter because nobody's going to use my software. We may never launch. It's fantastic. I also advise StackShare and GitLab too. Anyway, nobody wants the best. I have a philosophy about life, and I think nobody really cares about the best. Now everybody talks about it. We want the best everything, right? We only want the best language. We want to use the best framework and all this sort of stuff, and it's really exciting and fascinating and stuff. I don't think anybody really wants that. This is what they really care about. It's just like, for the love of God, just I hope my choice doesn't suck. Like if it's good, that's great, but I just don't want to lose really badly. Um, you've heard the phrase like nobody gets fired for buying IBM. This is literally the embodiment of the phrase. Like, it doesn't say anything about like IBM is amazing. It's like, no, you're not going to get fired if you use them because it's of an acceptable quality, and that's fine. I think this is like an important thing in life to start kind of figuring this stuff out. This is all over the place. You want to go to dinner after this? Cool, let's go to a good place. We're not going to go to like a 4 Michelin star place tonight. Like, that's ridiculous. Let's just go to a place that doesn't give me food poisoning. Like, that would be nice. Hiring is definitely the same way. Everyone's like, oh, we only hire the best people in the world. And it's like, no, you don't. I know some of the people that work there. They're assholes. You're lying to us. You just don't want to avoid the people. You just want to avoid the people that are maybe going to be terrible people. And that's fine. People will be more happy if they just kind of embrace this and just were like, okay, how do we deal with, hedging our bets and trying not to ruin our lives and stuff like that. So that's kind of where I'm at. As somebody who's starting a startup, we have no idea how this is going to go. I worry less about trying to have the best anything because, I hardly know what color my logo is going to really be. Much less like what my long-term decisions about our tech stack is going to be 5 years from now. But it's really important to us that the time that we do spend on this now, our limited time, is actually not going to ruin our company, in 6 months or something like that. Our future is unwritten. How do we make the best choices without really fretting out about like, is this the best combination of stuff that we can possibly do? So first thing I really want to talk about is a little bit about Rails. I've been using Rails for 12 years. I think Rails is still swell. I think it's lovely. But in general, like I can't really guess the future. I've never been good at sort of figuring out like, oh, what is going to be the cool hip thing in 5 years and stuff like that. It's really hard to do. Um, and you know the problem is like I'm a CEO now, so I'm like afflicted with having to deal with like growth charts and 5-year plans and other bullshit that will have no resemblance to reality at all. But you still have to start thinking about this. And again, I'm kind of thinking it from a cautious like, how does this not ruin our company type of thing. One of the things that my co-founder is Rick Olson. He worked at GitHub for 7.5 years. I worked there for 5 years. And one of the things that we kind of saw over the years is that GitHub was very locked into Rails for good reasons and for bad reasons. And kind of the things that we're kind of talking about, like how do we want to build a company and stuff like that. We don't want to necessarily get locked into the idea of being, oh, we're stuck with this language choice because of 10 years ago and stuff. And again, that's not knocking on Rails, it's not knocking on anything. It's just kind of the reality of, how do we punt these decisions down the line until we have better knowledge of where we actually stand with this problem or tech stack or whatever our approach is. So basically, yeah, how do we punt on these questions till we have more knowledge to answer them? Our current kind of stack right now is we started out with a big kind of Rails prototype because Rails is still awesome. Don't let anybody tell you it's not, even though I'm going to kind of say that a little bit today. Active Directory is still great, and when you're coming after the perspective of like, I don't know how this is going to actually look. I don't know what data models I need and stuff like that. Just the act of having DB migrate is amazing. You can do so many things with that. So like we kind of started out with Rails to make it a lot easier to sort of go a lot quicker and stuff like that. And we kind of ended up with a thing sort of like this, where we're starting now to sort of like slip in different Go services and stuff in places that we know are going to be potential performance problems, or we just want a little bit more solid understanding of like how our data flows throughout the system. Instead of like, I don't know if you know this, but if you just add callbacks to a Rails app forever, it'll never stop. It's just calling itself all the time. And we kind of want to get more to this place in the future. We'll probably wrap the whole thing in Go, but like Rails will still be like a foundation to a lot of this sort of stuff, because there's a lot of things that we're building right now where Rails is just like the best choice, even though performance is slower and it's not as hip and all that sort of stuff that people talk about in Hacker News and things like that. But we like think this is a pretty good approach, and we want to get there at some point. One of the things that makes this a lot easier to build out is kind of what we were just been hearing about the last few times. Like GraphQL is a really good tool to sort of give you a more cautious approach towards your backend and stuff like that. One of the best things about this is like schema stitching, in terms of like, hey, I have a big response of data that you just asked me. From the perspective of the backend, these different responses may come from completely different services, different languages, different frameworks. There's a lot of different approaches to stitching all that schema together into one response, either on the client side or on the server side. The client side has some interesting stuff in Apollo, if you're kind of tied to like a REST backend that you can't change and stuff like that. But all this stuff is really interesting, and there's some really interesting stuff down in the pipeline potentially for GraphQL that they were talking about. There's a proposal last summer before last, about defer and stream, which is basically like, I have a big long response that I want to send over GraphQL to you. This stuff may take a long time, so just return the entire response first, and then this stuff will respond, when it can. It's not like in GraphQL yet, but like that's the type of stuff that like it really opens up a lot of the world, where you're like, well, it doesn't really matter where my servers are, because like servers are old anyway. Like it's all serverless now and stuff anyway. But like that's GraphQL really makes this a lot easier to not have to be tied into your architecture decisions, kind of from the get-go. Coming from somebody who really hated microservices for a long time, and now I'm building a calendar, and I'm like, oh, it's not that bad. So that's kind of interesting. So that's kind of like one of the main things with like all of the stuff around Rails for us, is trying to stay as flexible as possible. And at one side of that, like, I think like Ruby is really good right now with how you have it play well with others. Like, can it be friends with a lot of different services? And I think that's one of the benefits of the Ruby stack and the Rails stack in particular, is like, how can you integrate things that make Ruby better when Ruby is obviously too slow or too not hip or whatever. But really leveraging Ruby for being as good as it is in a lot of these other circumstances. So yeah, Rails play with friends. React should never make friends with anybody. Here's what I mean by this. Also, this is my cat. I just stare in his dreamy eyes all the time. So first little thing here, it's really weird for me to talk about JavaScript. I've been writing JavaScript for like 20 years, like 1997, 98, Internet Explorer 4. Anybody there with me? Coolest fucking shit on the planet. Internet Explorer 4 was awesome. Web channels and stuff, so good. But the subsequent 20 years were terrible. I hated JavaScript so much. Really, really terrible technology. But the last year or two, I'm now like a JavaScript developer, like primarily, and it's really odd, and I like it. So yeah, times have changed. There's probably a lot of people here who are moving from the Ruby world, like me, into the JavaScript world. Like, what's like the Will Smith apocalyptic film where he comes out of the door and it's like everything's a chaos, but it's all different. Yeah, I am Legend or something like that. I'm Legend because I'm using JavaScript now. I don't know where I'm going with this one, but things have changed, and React is a huge part of that for me. And the reason why I say like lonely React, I think is a good thing, is that React makes it really easy to isolate everything down the stack, and everything that you've heard with regards to like React and stuff is probably totally right. Like add more and more components, use like single responsibility principle. Every single time where I just kind of sit down, like a couple days ago, I was like, why the hell am I doing 4 components for this? And then the next day I was like, oh yeah, this is a great idea. Now I understand. All that stuff is really great. Basically, like, don't give React too much to do, and it negates a lot of the terrible JavaScript stuff that I've had to deal with for like 20 years. It's really exciting. Like, if React is ever dealing with like the DOM whatsoever, if you're like manipulating the DOM at any point, that's probably a bad idea, and you should rethink your life, basically. So basically, like, Ruby should have a lot of friends, but like put React in the corner and like only feed it if statements. And like you'll be so much happier because everything's so much easier. Like I'm building the most complex client-side app I've built in my life, and I understand it more than some of the spaghetti Ruby stuff that I've written over the years as well, which is shocking to me. It's amazing. Again, GraphQL helps out a lot of this on the client side. In my kind of everlasting quest to like remove as much logic as possible, we've been pushing more and more stuff towards GraphQL, towards the server, and it ends up just making our lives a lot better. Matthew was kind of talking about like, he was hedging his bets with like, yeah, use Apollo because Relay is, like, I'm just gonna go straight out and be like, use Apollo, it's the coolest shit in the world. Relay, use Apollo, it's amazing. I really, really like it. Like, honestly, they are my favorite open source project right now. Like, the level of work that they've been putting in, the cool stuff they are doing with like some of the offline service cache or service worker caching and stuff like that is just like, I don't know. I'm really, really impressed. I love it. Reminds me of like Rails 2.3 and 3.0. Like, it was exciting days back then. I tweeted this a while ago. Never learning Redux is one of my proudest achievements in life. Still stand by that. I learned Redux a little bit, but like I think it's important to note that like you don't have to get too far down the rabbit hole of Redux and like Reduxizing all of your code and stuff like that. For me, like GraphQL gets rid of almost all the reason I would ever want to use like Redux or any type of like really stateful stuff on the client. And Dan, who actually created Redux, responded back like it's definitely overhyped, low level, and often used unnecessarily. Yeah, I was gonna put a really terrible joke there, but I think that's totally true. Like I think like Redux is awesome. I think it's a really good tool. It's just like so many people move for it right away, and then when they start realizing like, oh wow, this is a real pain in the ass. This is when you start hearing the things about like, oh, why do I have to use Redux or React for all this sort of stuff, and et cetera, et cetera. I don't want to talk too much about tooling, but I wanted to at least say these two things, like Prettier and Flow. Does everybody use Prettier? Prettier is like the coolest stuff ever. It's basically like a Go format, just formats all your code. I have deep-rooted feelings on semicolons, and now I don't because Prettier just does it all. Same thing with like Go format. Go format like chooses every single wrong decision you can possibly have for like formatting code. But I don't care because when I press save, it just and it's fantastic. Flow or a TypeScript or whatever the case is, as a Rubyist, like I want to just not have any types at all, and I just want like freedom and everything. Totally crap. Like JavaScript with like Flow has been really awesome, especially when you get towards like what Matthew was talking about earlier, like having types. And now we have types from Go through GraphQL through JavaScript, and we can have a really good understanding of like how our app is getting tooled. That's amazing. Between these two things, it makes my experience writing JavaScript better than Ruby, which is like pains me to say, but it's really really exciting. I know there's going to be somebody's been working on like a prettier Ruby, which is really exciting. I think it may be halfway dead or something like that. I know there's a couple other existing projects that are kind of working on that too, but um, basically Rubyists have too much freedom. Anyway, last little bit, React and Rails. Why we're here today. Um, okay, here's the spoiler. Don't. So it started out like the first kind of prototyping. We're building a calendar. It's heavily client side, single page app and stuff like that. What would become a single page app. I started doing like a lot more in depth experimenting with like how does React work with Rails and all this sort of stuff. And it just became clear to me like just if you have a fresh project and you're trying to do something new, just split them out completely. And there's a lot of reasons for that. Like for one, like the biggest point, the people who write Rails don't know JavaScript as well as the people who write JavaScript, frameworks and libraries and stuff like that. And it's not like I love the Rails core and stuff like that. They're amazing. It's just that like JavaScript moves pretty quickly. I don't know if you've noticed this, but like JavaScript's pretty wild. Like if on the number one on Hacker News tomorrow is like JavaScript community decides to deprecate npm, I'd just be like, yeah, sure, that's something they do. Whatever. But it moves really fast. It's really interesting. It's like the amount of resources getting poured into this one language, and like web browsers in general is staggering. And you kind of want to be in that river rather than having like a buffer between you and that channel of movement and stuff like that. And you start getting like all these gains for free, like tree shaking, code splitting. The more you kind of go into that area and let work on the client side stuff and let Rails do the fun stuff that it's really good at, the better off you're going to be. For us, like we do like a single page app. We ended up using like create. I can never say this out loud. Create React app. And it's fantastic. We haven't even ejected yet, and it blew my mind because like we just upgraded. It was last year, 6 months or whatever the case was. And we had service workers just like straight up. I was like, this is amazing. Then like a couple months later, they pulled it out because it was terrible. But like the fact that I had service workers for free for a little bit was so awesome. Next.js is obviously doing really interesting stuff too. All of this sort of stuff, like as you get closer towards the movement in a project and stuff like that, you start getting closer towards like the real reason to use React, in that Facebook is not going to screw up its own development internal workflows and stuff like that. So the upgrades path should always be there for you, and getting close to that, you don't want to have a buffer between you and that fast upgrade path and stuff like that. So that's mostly what I had to talk about today. I guess this is the point when, like, I should say, like, if you are a React developer and really into Rails and stuff, you should definitely look to be hired by Flexport. We have zero money. Or StackShare for sure. Pretty much anybody else, if you have a lot of money, you can give it to us or work for free. That's cool too. I accept cash. I won't declare it. Anyway, I'm just kidding. That's all I got. That's the weirdest way to end this talk. Thanks.
I think we can do questions if there are questions. I'm definitely not going to answer any, but you should. And Matthew and Stefan. Questions? Anybody?
Do we have public APIs for clients? Um, it's nice because we aren't launched, so we can do whatever we want. Technically, when we launch, it will be like public. It's not something that we'll probably like do like a big push for and say like, hey, you can build your own apps on top of us and stuff like that. But it will be a side benefit until we make that like a much, you know, standardized thing. Since we're not launched, how do we know what to build for our users? We're just we are the best at product. No, a lot of it is just like we've been thinking about this for a long time. It's kind of standard product stuff. Like I'm a big fan of building things that you have to use every single day. At least that was why I enjoyed working on GitHub so much. And calendar is very similar to me. Like I live in my calendar, so if I fuck that up, like it's on me. And there's a lot of really cool stuff that I've been thinking about for a long time. So, but it's one of those things like once we launch, we'll figure out like if we're totally screwed or make a lot of money or something like that. So during.com. Yeah, $20. I'm just kidding. No. Anyway, more questions? Our pricing model will be something about like SaaS sort of stuff. We're mostly going to be gearing towards companies. The number of people who will like actually pay for this for their personal accounts is probably like two. But we have some really interesting stuff in mind for like organization, scheduling, and stuff like that. So. All right. Cool. I'll be around.
Thanks, Zach. So hi everyone, I'm Desmond. I'm Director of Engineering here at Flexport. Really quick, Flexport is a freight forwarder, so that basically means we arrange to have like shipping containers moved across the planet. And that's a really old business, but we do it in a very modern way with a lot of Rails and a lot of JavaScript. And we actually like seem to be making a bit of money. So if you liked the projects that Matt or Stefan described to you earlier, and you want to work on stuff like that in React and Rails, come talk to any Flexport person afterwards, including me. And so with that, thanks for coming to the first React and Rails meetup. And yeah, have a good time. I guess next up, what have we got next? Yeah, just hang out, mingle. We've got some snacks and drinks, and yeah, come talk to me if you're interested in getting paid to work on React and Rails.
All right. Thank you, everybody.
Hey. Hey, are you the founder of StackShare? Yes. Cool. Yes, I am. That's awesome. I really like what you guys did. I don't know. I wanted to. All right. Yeah.